Imagine lifting a double-decker bus to the roof of a cathedral. Now do that 2.3 million times. With no cranes. No engines. No modern machines. That's not a thought experiment, that's literally what it took to build the Great Pyramid of Giza. And here's the unsettling part, even today, with all our technology, engineers still argue about exactly how they pulled it off. Built around 2560 BC for the pharaoh Khufu, the Great Pyramid was the tallest man-made structure on Earth for almost 3,800 years. Nothing came close until the Lincoln Cathedral was built in the 1300s. The numbers alone are absurd. The pyramid contains roughly 2.3 million blocks, weighing about 6 million tons combined. Each individual block weighs between 2.5 and 15 tons, that's like moving a fully loaded pickup truck, by hand, using only ropes and wood. And they didn't just move them. They lifted them, 481 feet into the air, and fit them together so precisely that even now, you can't slide a credit card between most of the joints. So how did a civilization with no iron tools, no wheels for hauling, and no pulleys as we know them today, build something this precise, at this scale? Here's the real engineering nightmare they faced. 3 separate problems, stacked on top of each other. Problem 1, the material. The blocks were carved from quarries using copper tools, copper, a soft metal, cutting through solid limestone and granite. In total, the project used an estimated 5.5 million tons of limestone, 8,000 tons of granite, and 500,000 tons of mortar. Problem 2, the transport. Some of that granite wasn't even local. Boatmen used the Nile and a network of artificial waterways to bring materials in, granite hauled all the way from Aswan, copper tools shipped from the Sinai Peninsula, and timber imported from Lebanon. This wasn't a local construction site. This was a logistics operation spanning hundreds of miles, with zero modern transport. Problem 3, the lift. Once the stone arrived at Giza, how do you get a 15-ton block to the 400-foot mark of a pyramid, with no crane? This is the part where, for decades, even professional engineers have disagreed. Let's break down what we do know, and where the real mystery still lives. Getting the stone to the site. This part is fairly well understood. The accepted theory is that workers dragged the blocks on wooden sledges, over specially built causeways made of either slaked lime or a local clay called tafla, and remains of these clay causeways have actually been found across the Giza Plateau. Wet the path slightly, reduce friction, drag the sledge with ropes and manpower. Modern experiments have proven this works. In fact, archaeologist Mark Lehner's team tested this exact method by building a smaller 18-foot pyramid using sledges, and it worked. Problem 1 and 2, basically solved. The real mystery, getting it up. This is where things get genuinely unresolved, even among professional Egyptologists today. According to Dr. Iman Gonian, a professor at the University of North Carolina Wilmington, there is still active debate among scientists over the exact method used to raise these heavy blocks to such extreme heights. Let that sink in, this isn't settled science. This is a real, ongoing engineering debate in 2026. The most widely accepted theory for decades has been the external ramp system. Egyptians allegedly moved blocks up large ramps, possibly greased with water or wet clay, using sledges, ropes, rollers, and levers, with some ramps zigzagging or spiraling around the pyramid as it rose. Sounds simple enough, until you do the math. A ramp gentle enough to drag multi-ton blocks up, reaching 481 feet, would need to be absurdly long. Some estimates put it at over a mile, requiring more material than the pyramid itself. Engineer John Cunningham proposed an alternative, flexible poles that combine the weight distribution of a suspension bridge with the energy-storing principle of a bow. Clever physics, but most experts agree it doesn't solve the moving a mile-long ramp's worth of material problem. The internal ramp theory. This is where it gets interesting. In 2018, archaeologists from the French Institute of Oriental Archaeology and the University of Liverpool discovered a 4,500-year-old ramp mechanism at Hatnub, used to lift heavy alabaster stone out of a quarry, and this same method may have been used at the Great Pyramid itself. French architect Jean-Pierre Houdin took this further. He proposed that the first 30% of the pyramid was built using a normal external ramp, but beyond that height, an internal spiral ramp, built inside the pyramid's body, took over. This would also explain a real archaeological puzzle: why almost no physical evidence of a giant external ramp has ever been found, because the ramp stones were recycled into the pyramid's own upper layers. And this isn't just an old theory gathering dust. As recently as April 2026, new research using advanced 3D modeling proposed essentially this same idea: a hidden internal integrated edge ramp spiraling upward inside the structure as it was built. The simulations behind this research suggest the pyramid could realistically have been completed in roughly 20 to 30 years, with workers placing a new block every few minutes. That number matters. It turns an impossible project into a plausible one, if the internal ramp theory holds up. The wild card theory. Not everyone agrees on ramps at all. One 2025 study published in NPJ Heritage Science proposes something completely different: a pulley-like system using counterweights on sliding ramps, possibly using the pyramid's own internal descending passage as a mechanism to lift blocks at the structure's edge. So even now, in 2026, there isn't one agreed-upon answer. There are at least 3 serious competing engineering theories, each backed by actual physics, actual archaeology, and actual published research. Here's what makes this genuinely unsettling for modern engineers: we have cranes that can lift 1,000 tons. We have laser-guided construction. And we still can't conclusively prove which method a Bronze Age civilization used to build the most geometrically precise large structure on Earth. Modern construction teams have tried to replicate parts of the process, and even with full understanding of physics, ropes, and ramps, they struggle to match the speed and precision the ancient builders achieved with what we'd now call primitive tools. The Great Pyramid isn't a mystery because we lack imagination. It's a mystery because the ancient Egyptians solved an engineering problem so well, they didn't leave behind a clear record of how, because to them, it probably wasn't mysterious at all. It was just Tuesday. So next time someone tells you ancient civilizations couldn't have built something without outside help, remember, the real answer isn't aliens. It's logistics, physics, and an almost unbelievable level of human organization. If you want to see the next forgotten engineering marvel that still baffles experts today, hit subscribe, because next time, we're looking at a 2,000-year-old structure that has zero cement, and is still standing stronger than buildings we make today.